Dear students, today I will discuss about constant equation. In the previous lectures, I have discussed about the mass pulley system, and in that case, we have dealt only with one pulley system. But when there is more than one pulley, that is the system will be more complicated. Then we cannot deal by our prediction. So we have to search some mathematical aspects or some mathematical way of thinking the system, and that mathematical way of thinking the system is actually constant motion. And this concept is coming from the Lagrangian and Hamiltonian mechanics. That is, the constant motion is coming from the degree of freedom, from the generalized coordinate, that is in configuration space. But here I will simplify the theory and I will apply in the mass pulley system. So in the previous lectures, I have first discussed with you a very simple thing, that is, if there is one pulley and two masses, that is, one mass is m1 and the other mass is m2, like this. These two masses are hanging like this, and if m2 is greater than m1, then the system will move in this direction. So we assume that the motion of the m1 will be outwards and the acceleration is a, and the motion of m2 will be downwards because m2 is greater than m1. Now this was our prediction. This is actually our prediction. From experience, we know that the system will move like this. But when there will be more complicated system, that there is number of pulley will increases, then this prediction will fall. We cannot predict the system in which direction the system will go. In that case, we have to use the constant motion. So first we find the relation of this acceleration between m1 and m2 by constant equation for this simple system. Then we will go to the complicated system. So for that case, we will simply apply a trick, that we will find the position of m1 and m2 first with respect to a certain reference line. So if we take a reference line over here, and the position of mass m1, let me take it as x1, and the position of mass m2, let me take it as x2. Okay. Now, as the string is inextensible, this is the constant condition, this is the restriction. Constant means actually restriction, and here the restriction is the string is inextensible, that is, the length of the string is fixed. So if the length of the string is fixed, then we can write x1 plus x2 is equals to constant. This is actually the constant equation, and this equation gives me the relation between the position of these two masses. And once we can find the position of these two masses, we can easily find out the displacement, we can easily find out the velocity, we can easily find out acceleration also. So if we take the derivative of this with respect to time of this position, then we will get dx1 by dt plus dx2 by dt is equals to 0, and this is nothing but dx1 by dt is velocity of this mass m1, so it will be v1 plus v2 equals to 0, and from here we can calculate that v1 equals to minus v2. So the velocity of this mass m1 will be positive in the positive. If we take upward direction is the positive direction, so v1 will be in this direction and v2 will be in this direction. Now if we take derivative again, then it will be the acceleration, that is dv1 by dt equals to minus dv2 by dt, that will be nothing but a1 equals to minus a2. So this is the mathematical finding of the relation between the acceleration of the two masses m1 and m2, that is a1 equals to minus a2. So mathematically we can find that the acceleration of this mass m1, if this is in upward direction, then it will be in downward direction, and as a1 equals to minus a2, we can simply write it a. That was our prediction in the previous case when I have discussed with you simple mass pulley system. We can use our prediction and we can get the result. But here we don't use the prediction, we use the mathematical expression and the mathematical rule, that is the constant equation, and we will do the problem like this. But and this is more useful when the number of pulley will increases. Okay, when the number of pulleys increases like this, if you take here one pulley, one extra pulley, and there is two mass again, that is M2 and M3, then our prediction it is very difficult to predict the relation between this acceleration. So in that case we use the constant equation, and we will always fix the length of each string, and we will get the relation between the acceleration. Okay, so the more complicated systems I will discuss in the later lectures. Okay, thank you.